Hello everyone, welcome to Mpumalanga's Maths and Science YouTube channel. And today we are looking at the grade 12 physical science paper from Mpumalanga, Department of Education. This paper was written in June 2022, and today's topic is momentum and impulse, which was question 5. Now they have a block A with a mass of 1.7 kilograms that moves at 8 meters per second to the right on a smooth horizontal surface. Block A collides with a stationary block B with a mass of 2.5 kilograms. And after the collision, block B moves to the left at 0.3 meters per second. Now, the first question asks about stating the principle of conservation of momentum in words. And let's get right to it. At 5.1, they want the principle of conservation of momentum. Now, the principle of conservation of momentum states that the total linear momentum of an isolated system is conserved. Now, the statement basically means that the momentum before a collision in an isolated system and the momentum after a collision in an isolated system is the same or is equal. Okay, so let's have a look at 5.2.1. They say calculate the magnitude of the momentum of block A before the collision. So before the collision, we need to list how much do we have here. This is the data for before the collision for block A. So let's take that down. In 5.2.1, we're looking for data for A, which is a mass of 1.7 kilograms, velocity of 8 meters per second, and you're looking at the momentum. Now the momentum is what? The mass, product of the mass and velocity. So it's P is equals to mv. And if you multiply that, it's 1.7 times 8, and that'll give us 13.6 kilograms meters per second. Then in 5.2.2, calculate the speed of block B after the collision. Now, after the collision, we don't know what happens to B, whether it goes left or it goes right. So we have to use or apply the principle of conservation of momentum. And how do we apply the principle of conservation of momentum? So this is 5.2.2. We need to state our data. For block A, we have the mass, which is 1.7 kilogram. We have the velocity initial, which is 8 meters per second. And then we have the velocity final, which is negative 0.3. Then for block B, we have the mass of 2.5 kilograms. And then the velocity of block B, initially it was stationary, so it's a 0 meters per second. Then velocity final is what we are looking for block B. Now, how do we apply the principle of conservation of momentum? Now, it says that the sum of the momentum initially is equals to the sum of the momentum finally. Now, Momentum is mass, so it's mass 1, velocity of velocity 1 initial plus mass 2, velocity 2 initial, which is equals to mass 1, velocity 1 final plus mass 2, velocity 2 final. Then we substitute, and this is 1.7 times 8 plus 2.5 times 0, which is equal to 1.7 times negative 0.3 plus 2.5 multiplied by V2 final. And then we're going to get a 13.6 plus 0, which is equal to negative 0.51 plus 2.5 V2 final. Now this is 13.6 plus 0.51, which is equals to a 2.5 V2 final. Then we divide both sides by 2.5, and then we get V2 final is equal to 5.64 meters per second to the right. To the right because it's a positive value. Next up, during the collision, the blocks are in contact with each other for 0.4 seconds. And you have to calculate the magnitude and direction of the force that block B exerts on block A during the collision. Now the force that they're talking about is the net force. So in 5.3, you're looking at the net force, which is given by change in momentum over change in time. Now it's either use information for B or information for A. I'm going to start with using information for B. Now for B, the mass is 2.5 kilogram. Velocity final is the one we calculated as 5.64 meters per second. Initially, this was a 0. So this is mass times V final minus V initial over change in time. The change in time has been given to be what? 0.4 seconds. Then if we substitute, we get 2.5 multiplied by 5.64 minus 0, all divided by 0.4, which then gives us a number which is 35.25 newtons to the left. That is the force that block A is experiencing, because the question asks us that the force that B exerts on A. But we know we can also use information for A as what does A feel. So block A feels the mass is equals to 1.7 kilogram and V final, which is 0.3, negative 0.3 meters per second, and a V initial, which is 8, so that we can get the F net is equals to M VF minus VI over delta T, which comes from F net is equal to change in P over change in time. Now substituting, we get 1.7 multiplied by a negative 0.3 minus 8 all over 0.4. And the answer we get here is slightly different, which is equal to 35.28 newtons to which direction, where it's a negative, and then we change that to a 35.28 newtons to the left. Then the last question says, determine by means of calculations if the collision is elastic or inelastic. We're going to check if the collision is elastic or it's inelastic. So, just a quick word to check whether a collision is elastic or inelastic. We need to calculate the sum of the kinetic energy before collision and after, separately, and we compare and make a conclusion. So here, let's start with the sum of the kinetic energy before the collision. We already know the values, so we're going to go straight to the calculation. This will be half m1 v1 initial squared plus half m2 v2 initial squared. And before the collision, we know that we had a 1.7 kilogram multiplied by 8 squared plus half of 2.5 multiplied by 0 squared, since that one was stationary. Then we get the sum of 54.4 joules, and that is the kinetic, or sum of the kinetic energy before the collision. Now, sum of the kinetic energy after the collision was given by half m1 v1 final squared plus half m2 v2 final squared. Now this is equal to a half times 1.7 times negative 0.3 squared plus half times 2.5 kilograms multiplied by 5.64 squared, and then we get a sum of 39.84 joules. Then we now make the comparison, and we find that the comparison is that sum of EK before is not equal to sum of EK after, and therefore the conclusion is that the collision is inelastic. So it means some of the energy got lost in making sound and heat and the impact on the crash or the collision. Okay, and thank you for watching our video, and keep on subscribing and liking, and see you in the next one. Thank you so much.